It's just 4.2 light-years away, but it appears practically unfathomable that we will ever reach Proxima B. This is all the more unfortunate given that the celestial body is not only the closest exoplanet to Earth but is also considered potentially habitable. Given that we are not even succeeding in conquering the planetary world right next to home, one might think that interstellar travel will remain an unfulfilled dream forever. But it doesn't have to be that way. In fact, experts are now working hard on the development of new propulsion systems that will soon enable us to jump to the stars, finally bringing exoplanets like Proxima B within our reach. But what groundbreaking concepts are being discussed in this regard? How feasible is their implementation, and could Proxima B actually become our interstellar springboard? If anyone knows how to explore the vastness of space, it's the two Voyager probes. No wonder, as Voyager 1 and 2 have now covered impressive distances of 24.67 and 20.62 billion kilometers from the Sun, respectively. This corresponds to 165 and 138 astronomical units, and thus not even a single light day, which is estimated at around 173 astronomical units. When we consider that Proxima B is about 4.2 light-years away, we realize that the Voyager probes would need to fly another 70,000 years before they would reach our planetary neighbor. And it's worth noting that these sister probes are not leisurely cruising through space but are racing through interstellar space at around 61,000 kilometers per hour. Nonetheless, the title of the fastest human-made object goes not to Voyager but to the Parker Solar Probe, launched in 2018, which reached an astonishing speed of over 635,000 kilometers per hour this July. However, even this artificial, Speedy Gonzales, would need several centuries to arrive at the Proxima Centauri system. As we now know, the enigmatic red dwarf in the constellation Centaurus doesn't journey through the universe alone. On one hand, Proxima Centauri is part of a triple star system, which includes Alpha Centauri A and Alpha Centauri B. On the other hand, it also represents the central star of a planetary system that includes at least 3 members, especially Proxima B, discovered in 2016. This exoplanet consistently attracts astronomical interest, which isn't surprising since we're dealing with a rocky planet in the habitable zone that scores an impressive 0.87 on Earth's similarity index. To explain briefly, the habitable zone refers to the distance range within which a planet must be located relative to its host star for water to exist there in a permanently liquid form. The Earth Similarity Index shows how much an exoplanet resembles our home in terms of energy flow, mass, and radius. However, does this mean that Proxima B is a cosmic twin of Earth? Is Proxima B Earth 2.0? Not quite. Though one thing is certain, with a mass of 1.17 Earth masses, it's generally labeled as an Earth-like exoplanet. However, the term Earth-like only refers to rocky planets with solid surfaces and doesn't give any information about their habitability. While Earth is known to take 365 days to orbit the Sun, Proxima B only needs about 11 days for one orbit. This is simply because the distance between the exoplanet and its host star is just 7 million kilometers. Moreover, there's increasing evidence that Proxima B has a tidally locked rotation, meaning it always presents the same side to its host star. Consequently, its surface is divided into an extremely cold night side and a significantly hot day side. There might, however, be a narrow strip between these two extreme zones that allows life to thrive. Yet, according to our current data, water would also be necessary for that development, and the appropriate orbital parameters and a favorable atmospheric composition are crucial. Simulations have shown that liquid water could indeed be splashing around here in abundance. However, it's essential to note that we're dealing with a hypothetical model. In reality, many parameters crucial for the presence of liquid water have not yet been thoroughly investigated. There's also the issue of radiation. Although Proxima Centauri, a red dwarf, has only about 12% of the Sun's mass, it drew attention a few years ago with an extraordinary radiation burst. Researchers at the University of Colorado observed that the star increased its ultraviolet radiation by a factor of 14,000 in a matter of seconds. This massive flare was thus over 100 times stronger than any solar flare recorded to date. Furthermore, the flares on Proxima Centauri are not only significantly more intense but also much more frequent than in our solar system. Considering this, the bleak forecasts suggest that the intense radiation from the host star could eventually destroy Proxima B's entire atmosphere and halt the development of life permanently. However, there is a scenario where the exoplanet might survive the turbulent radiation eruptions of its host star. For this to happen, it would need a liquid core that forms a stable magnetic field, which could deflect the radiation and prevent oxygen and water molecules from escaping into space. Moreover, it's possible that Proxima B is still drawing from its original water reservoir. One theory is based on the assumption that the planet initially formed at a much greater distance from its host star and was only later captured by it. Some simulations have shown that there might have once been several times more water on Proxima B than on Earth. Even if it has already lost 90% of its water due to extreme stellar radiation, there could still be enough today for a massive ocean covering a large part of the planet's surface. Yet, due to its tidal locking, the water could only exist in a permanently liquid form in the narrow twilight zone. On the day side, it would be more like a boiling pot, while on the night side, it would freeze into ice. Will we ever reach Proxima B? Both Voyager probes are powered by radioisotope thermoelectric generators, which convert heat from the radioactive decay of plutonium into energy. However, as already mentioned, it would take humanity's most distant probes tens of thousands of years to reach the Proxima Centauri system. So, what do you do when old propulsion technologies have had their day? That's right, you turn to solar sailing. Indeed, what might seem like a dusty idea at first is, in fact, the core of the revolutionary breakthrough Starshot research project. While its financier and billionaire Yuri Milner may not be one of the most famous faces in space research, renowned scientists like Stephen Hawking, Avi Loeb, and Freeman Dyson have also participated in the project, which began in 2016. Essentially, Breakthrough Starshot aims to demonstrate that it's not only possible but feasible to send a spacecraft to the realms of Proxima Centauri in just 20 years. But how is that even possible? How could the estimated travel time of 70,000 years be reduced to this almost absurdly short time frame? Essentially, where great ambitions exist, sometimes smaller steps are required to achieve them. Specifically, the plan is to launch nanoscale probes weighing only a few grams into space. These solar sails would then be illuminated by a powerful Earth-based laser, and the light pressure would accelerate the tiny probes to 20% of the speed of light in a remarkably short time, enabling them to achieve the desired Starshot breakthrough. This technique, called sailing a spacecraft equipped with light sails, isn't new. The American physicist Robert Forward proposed it as early as the 1970s. However, this particular propulsion concept has unique requirements. To reach the necessary speed of 60,000 km per second and withstand acceleration of tens of thousands of Gs, the components must be scaled down significantly. Outrightly, more explicitly, the Starshot project envisions the advancement of a small spaceship, the size of a computer chip. This would comprise just a coded control PC, a power source, a camera, a receiver, a transmitter, and a solar sail. However, only developing this technology isn't enough on its own. As mentioned, it also requires an Earth-based laser push. In detail, it would require not just one but a massive array of lasers combined to form a 100 gigawatts beam aimed at the 4 by 4 meter area of the solar sail, 20 million kilometers away during the acceleration phase. If successful, a laser beam of only 10 minutes could pave the way for the nanoprobe to reach Proxima Centauri. Yet, doesn't this all sound somewhat optimistic? After all, the tiny spaceship would then somehow need to decelerate at the target. Calculations show the probe would need to decelerate from 20% to around 4.6% of the speed of light to avoid speeding past the target star system within moments. In this regard, some scientists suggest it might be better to abandon the idea of a giant energy-consuming laser and instead use solar radiation. In this scenario, however, it would require a sail around 100,000 square meters in size, made of a lightweight but robust material, such as graphene. Similarly, natural starlight could be used for the critical deceleration maneuver. When the probe is about 5 astronomical units away from the triple star system, it could turn its sail around to slow down using the illumination of the stars ahead. A programmatic simulation has shown that the braking effect of light, combined with the gravity of the stars, could indeed allow the probe to swing into the system. However, such a process would take time, extending the journey from 20 years to an incredible 100 years. Even more patience would be required if the probe were also to reach Proxima B. In this case, the total flight time is estimated to be up to 140 years. At this stage, it's still not possible to say which adjustments the researchers might make in the future and which variation they will ultimately select. The researchers involved estimate that development alone will take 20 years. But it can already be said that, at least on paper, the challenges of such a mission can be overcome, and in the not-too-distant future, humanity might succeed in leaving its home system and studying exoplanets up close. Thank you for watching this video. I hope you enjoyed this journey into the mysteries of the universe. If you found this video interesting, please give it a thumbs up and share it with your friends. Don't forget to subscribe to my channel for more amazing updates.